Hello. So in the past, we had seen congruency. So we will not go to congruency again. But today, what we are going to cover is something called as a similarity. So for two polygons to be similar, there are two properties which should be matched. Number one property is that their corresponding angles should be congruent. If I say this and this is similar, first property, let me say ABC and let me call it XYZ. So first property is corresponding angle should be equal. So that is the first property of similarity. And the second property is the proportion of their sides shall also be equal, which means AB is to XY should be equal to uh, BC is to YZ is equal to AC is to XZ. So number one property, angles congruent. Number second property, length of corresponding sides are proportional. Okay, so those are the two properties. And how do we write that? We will write it congruency. We used to write like this, equal to and a tilde. For similarity, we just have to write like this. So if I say triangle ABC is similar to triangle XYZ, then I will say like this. Okay, so hope it is clear till here. Now let's move forward. So one important definition is the ratio of pair of corresponding side of two similar polygons is called the ratio of similitude. So this ratio will also be called ratio of similitude. Okay. First thing which we understood it is that this is called ratio of similitude. Similitude. And now the theorems. The ratio of parameters of two polygons is equal to the ratio of similitude. Meaning the parameter of ABC, parameter of XYZ. Okay, if I take parameter of these two and their ratio, it will be same as ratio of similitude. Ratio of similitude is what? Side, ratio of side. Okay, so it will be same like AB is to XY or BC is to YZ or AC is to XZ. Same is for the area theorem also. So if you say the area of two polygons, and it will be square of the ratio of similitude. I'm just writing S, but if it is area of ABC and area of XYZ, then it is square of, okay, ROS, ratio of similitude square. If these two triangles are given as congruent, then the ratio of their corresponding sides AB is to DE shall be equal to BC is to EF and shall be equal to AC is to DF. So if you take the ratios, everything is 2. And for two triangles to be similar, we already understood corresponding angles are congruent, they should be same, and corresponding sides are proportional. And this proportionality, this ratio is called ratio of similitude. Similar polygons, in the similar polygons also the same properties will apply. The corresponding angles shall be congruent. So you can see these angles are congruent and the ratio of corresponding sides is equal. So this is the second property. Here there is a square which is given and the square satisfies both the properties. First, the angles of a square are 90. So all the four angles are congruent, and then the ratio of their corresponding sides is also equal. So this square is similar to this square. These two triangles are given as similar. Their parameter would be the sum of all three sides. If you add the 10 plus 16 plus 12, and if you take the ratio of this parameter with the ratio of another parameter from a similar triangle, then the ratio shall be equal to the ratio of similitude. Okay, ratio of their corresponding sides. So you can see here also it is 2 and here also the ratio was 2. So this is the property of parameter in case of similar triangles. These two triangles are similar. Because these two triangles are similar, you have to calculate x first. So x would be equal to how can you calculate that? So you know in similar triangles, the ratio of similitude is equal. So ratio of similitude here is 15 by 5 or 12 by 4. And if you do that, it will come to 3. Okay, ratio of similitude is 3. So this means that 9 by x shall be how much? It shall be 3. It will be equal to ratio of similitude, and thereby x is equal to 3. If you solve this equation, you will get x equal to 3. So then you calculate the area of these two triangles. The area of triangles is half base into height. So the first triangle's area is 54 and second triangle's area is 6. And if you take the ratio of their areas, it is coming as 9. 9, which is equal to what? 3 square. 3 is ratio of similitude. So it is square of the ratio of similitude. That's what this theorem says.